Hello and welcome. In this video, we're going to be talking a little bit about factorizing expressions. It's a really important skill that builds off of the back of expanding. Often students find this a little bit harder, but it's okay. We're able to work through it so that we can understand it. Okay. So before you are starting any of the skills in this video, the first thing that I need you to do is I need you to be really comfortable with the idea of expanding. Okay. Which is just essentially where we go and remove the brackets heading along this way. And I need you to be comfortable with expanding things in different forms. For example, recognizing when to go and expand binomial products, for example, things that look like this. And being able to expand special types of those products as well so that you're able to recognize what they are going in reverse. So, for example, we'd be looking at difference of two squares and those sorts of things. So just be comfortable with that before you walk into this video. It's handy to be at least fluent before we sort of carry on with anything else. Now, if you are watching this video, the assumption is that you've at least touched on some sort of factorizing before. Um, it's almost like the reverse process of expansion where we go and add in brackets by collecting like factors or common factors across each of the terms. So you'll notice in this particular example, we have two terms. We have a 3x and we have a positive 6. The highest common factor between both of those, if we were to sort of break those apart, is that it looks like this. There's actually a 3 sort of attached to both of the terms there that we can drag and put out the front. So what are we doing at the end of the day? Essentially what we're trying to do is we're trying to reverse the process so we can create an expression that if we were to expand it using the distributive law, we would end up with what we started with. Okay, so we're essentially going backwards in a way. Okay, so again, I really want you looking for in each of these examples common factors. Okay, really important for you to be able to find. If you can't find the highest common factor of all of the terms, then you try and find the one that's most obvious to you, and it might pop out other factors that you didn't necessarily see before. So you don't have to factorize everything in one step. You can often break it down, sort of approach it as a couple of steps. So I figured we might jump in and get started on a couple of the examples. Okay, this is just looking primarily at just common factors here. Okay, so factorizing the following. You'll notice here um, that we have two terms. We have a 7 and we have a 42. If you think about the refresher, okay, that's me essentially saying I have 7 times x for the first term and 7 times 6 for the second term. So you'll notice that on both of them, we actually have this common factor of 7 for both of the terms, okay? So that's essentially the thing that we can collect and put out the front of the bracket. So we're reversing it, we're adding in brackets, 7 outside of x plus 4, oopsie daisy, outside of x plus 6. Now, once we've gotten to this answer, if you're not sure if you've got the correct answer, you can check by expanding your final answer. And if you get back to the original, then you should know that you've done it correctly. So 7 times x is equal to 7x, and 7 times positive 6 is equal to positive 42. Okay, providing that you have done this step correctly and you get back to the original answer, then you are 100% correct. Okay, if you notice any variation from your original answer once you get to this, then you've made a mistake somewhere here in your collecting of like terms, exactly like what I did a moment ago where I didn't necessarily change my term. Very common. Okay, all right. Now let's have a look at question 2. Okay, what you're looking for here in relation to question 2, you're looking for a common factor. I look at both the numbers and letters separately. So I'll look at the number 16, I'll look at the number 24, and I'll notice that there are a couple of different numbers that go into 16 and 24. For example, the factors of 16 include 2, they include 4, they include 8, and they include 16. Okay. Making sure that you try and pick the ones that are the highest between both. So looking again at this one, we have 2, we have 4, we have 6, we have 12. We also have 24 as well. You can include the number itself. Sometimes that is actually quite handy to actually see. Um, The other thing that you can also include as well is also the factors of 8 and 3. It's often good to try and write out your times tables for everything that goes and gets you to 24, 1 times something, 2 times something, 3 times something. So that way you don't miss any factors. And you'll see immediately that we end up with this highest common factor of 8 being in both of them. Now, I'm taking a little bit of time here. I'm probably going a little bit slow, but I really want you to understand essentially what we're doing. We're dragging the common factor of 8 out of both of them. So then I ask myself, well, what do I multiply 8 by to get to 16? That's right, the answer is 2. Okay, and I don't have any letters that I've dragged out, so that I write the letter M. And then I do the same thing for the second term. So plus, and now I ask myself, what do I multiply 8 by to get to 24? And the answer is 3. And I haven't changed any of the letters there, so I'm left with 3N. We could have done that in more steps. It just means that we're a little less efficient. Okay, for example, over here we have 16M plus 24N. We could have done any of the other factors over here. For example, we could have done 2, we could have done 4, and they still would have worked. They're just not as fast. That's why we pick the highest common factor. If I do the common factor of 4 that goes into both of them, okay, so drag out the common factor of 4, same process, right? What do I multiply 4 by to get 16? The answer is 4M. And then I do the same thing. What do I multiply 4 by to get to 24N? And again, the answer there is 6N. Now you'll notice here that these look like inside of the brackets that I have some more common factors that I can go along with, okay? And the answer is, if I do, I haven't fully factorized. So I'm looking to make sure inside of both of these, there's no common factors inside of any of the terms in the bracket. So factorizing those out, let's just zoom that out a little bit, my apologies. Okay, factorizing those out, I now end up with, because they have a common factor of 2 in each, I now end up with 4 times 2 outside of 2M plus 3N, and I can do the same thing that I've done before. So I'm just moving that factor of 2 out, and I can tidy up this, this term out the front, that factor out the front. You notice 4 times 2 will give me 8, and I end up with the same answer, but I'm taking more steps, okay? The answer is up to you. You can completely and totally take more steps if you want to. Sometimes if you have a particularly hard expression to factorize, you may need to do that, okay? Now, in this particular case, you'll notice that there are a couple of things that are different. You'll notice that they're both negative terms. So what we want to do with these particular things is we want to make sure if they all have a negative, then we want to drag that negative out as well. It makes the inside of the expression a little bit easier to work with. Particularly if we're doing equations. We're not doing that now, but it is a handy habit to have for in the future. So we're going to look at the first and the second term. You'll notice they both have a common factor of 3 in both of them. 3 is the highest factor for both, and they're both negative. So I'm going to drag out a negative factor of 3. And this is where I want you to be really, really, really careful here. Now that I've dragged out this negative factor, I have done something to the signs inside of the bracket. I have made them all positive, and I'll explain why in just one moment. Okay, this is a bit of a heed my words moment. Ignoring the negatives for just one moment, I want you to look at 3 times what gets me 21, and the answer there is 7. And I have an A attached to that term, and then I do 3 times what gives me 3, and the answer for that is 1. Now, the reason why I have made both of these positive on the inside after I have dragged out a negative is because I need to be able to expand and get back. So in orange, if I do minus 3 times 7, okay, I get minus times a positive is minus, 3 times 7 is 21A, and then minus 3 times 1, minus times a positive is a negative, and then 3 times 1 is 3. A very, very common mistake I see students do is not drag out that negative, or if they drag out the negative, they leave this on the inside. And that is a very, very common mistake. So what I want you to remember as a point of importance as we move through the next couple of examples, make sure that you factorize the negative out if you can. And if you do, switch all of the signs on the inside of the bracket. Okay? All right. Continuing on, sometimes we have to factorize out the algebraic variables instead of are just the numbers. So it's not always just the numbers that we are after or the coefficients. Okay. In this particular case, you'll see we've got an x on both. I can rewrite that as x times x. And this is minus 2 times x times y. Now you'll see very clearly I've got an x that is common on both terms. So when I factorize that out, I can drag that out the front. I'm left with just an x for this particular expression. And for this particular expression, because I've removed the x, I'm left with a minus 2y. That's my answer. Okay. Making sure as you go through, you'll notice in each particular case, we've just factorized out just one particular thing. Here's another example of the negative. I'll let you pause here, noticing that it says to factorize completely. So you don't want to stop with only factorizing one particular factor out of the expression. You want to go the whole way. I'm going to pause here if you'd like. You can have a little bit of a chance to move on. So, and try these yourself. This is a good little bit of practice for you. Okay. Now, if you're still with me, I'm going to go through how you do the first one. Noting that on the first and second term, they both have a common factor of 4, and they're both negative. So I'm going to drag the negative 4 out the front, and now I go, okay, well, minus 4 times what gets me minus 4x, and that is positive x, so the sign has changed on the inside. And then minus 4 times what gets me minus 48, okay? Again, ignoring the negative there just for one moment, okay? What you are after is 12. 4 times 12 will get you 48. And then I just need to make sure that on the inside, I have changed both of the signs to now become positive. Okay, now on to the next one. Looking at this, what you want to do if you have complicated expressions that have multiple variables that need to be pulled out, you want to look for the highest power that is across both of them, depending on the variable. So we're going to do this across 2 steps so you can see what's happening. I'll do the first step in blue. I'm going to be looking in particular at the m's, okay? The highest power for both of them is 2 for the m's. So if I drag out an m squared, inside of the brackets, I am going to be left with an n squared for the first term, okay? Plus, and now noting that I have 3 m's on this second term, so I'll still be left with an m on that one, and I'll still be left with an n squared. Okay, for my second start, you'll notice they both have an n squared in there. So I'm going to drag that factor of n squared out. So I'll have m squared, n squared outside of. Looking here, I'm going to end up with just the factor of 1 left inside of the bracket, not 0, which is a common mistake. It is 1. Plus, here I've removed the n squared, leaving me with just m. And that is my answer for that fully factorized expression there. Okay, all right. So in our next video, we're going to talk a little bit about factorizing difference of 2 squares, and then we're going to move on and use this skill again for factorizing expressions that require grouping in pairs. Okay, thank you very much.